Hello, everyone, and welcome back again. Glad to see you all. And we are unpacking with you today grade 5 energy. And so this is the second last one that we have. We have one more to go, and that would just be specific to the 456 group, which is that on space. And joining me today is my favorite partner and best partner in the world. And I'll let Ted introduce himself.
Thanks, Chris. You're always so kind with your words. Hi, everybody. Welcome. I'm Ted Zeroni. I'm a consultant, because I forget the other title we have, with the Edmonton Regional Learning Consortia. It's a pleasure to be here with you to unpack this grade 5 energy organizing idea for the new science curriculum.
So we are going to dive right into this, and we do have 2 outcomes in grade 5 energy. So that's a little different than what we've had in the past. Always sort of been one, maybe multiple cusp to it, but not 2 learner outcomes. And this time we do have 2 of them. So we're going to unpack those in kind of 2 different sections of the slide deck. Again, you would be able to choose whichever order you were going to do them in. It not necessarily in the way that we're going to do them, but there could be some linkages from 1 to 2 if you do it sort of in the intent of it. So maybe just be aware of that as well. So for those of you who have been joining us for energy in K to 4, we had the Grandfather's 7 teachings in our acknowledgement. But I did say I was going to change that out, and I did. And I've replaced it with the Legend of the Northern Lights. Now, the Legend of the Northern Lights will be a little bit different depending on who is telling it. But in this case, the majority of the story will be always the same. But it fits so well into energy because if you think of how the Aurora Borealis comes to be, it fits lovely into the energy unit that we're unpacking. So again, this will tell you the beliefs and the story behind the Northern Lights, and why it is the way it is, and who is up living in the sky, and what is the purpose? What do Indigenous people believe is the purpose or the meaning behind Northern Lights? So I will leave that to you. It's about a 7-minute video, but it's a beautiful story, and it's very appropriate for any grade level. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So we are unpacking sort of the tale that's been going all the way through now from kindergarten to grade 4, and definitely been some very distinct spirals of content that are important for students to know as they're moving through. There's a few now that we can kind of remove a little bit in one of the grades, but really there is some key terminology that we'll try and share with you as we go through and unpack this, of things that the students might need to have in their back pocket a little bit, so that if you thinking they're not knowing it, that you can maybe go back and grab some of the slides here, or you can grab some of the slide decks from the previous grades because you have access to all of them. So we're going to unpack those and give us sort of the big picture overview. So I'm going to turn it over to Ted, who is going to start that off for us.
Thanks, Chris. You've heard Chris mention the words spiraling curriculum and phrases like that, and that's definitely a change from what we've had in the old curriculum. This graphic here is just a representation of what that old curriculum was like. They were separate, what we call silos. That's what those images are intended to be, grain silos. And they contained all the things necessary for that grade's science course. So for grade 1, the silo contains seasonal changes, for example, needs of animals and plants. In grade 5, electricity and magnetism was in that silo, mechanisms of using electricity, and so on. And for the most part, each of those topics, what they were called in the old curriculum, all the information and knowledge within that topic or that unit ended up remaining in there, unless there was some purposeful planning to take some ideas out from electricity and magnetism and attach it somewhere else, and so on. That took some purposeful planning, and we could teach the year without doing any of that. Same with the grades themselves. Everyone could teach their own grade science course and not worry too much about what the next year science teacher needs, because they're for the most part pretty much unrelated or disjointed, I guess, for another way to look at it. But the new curriculum we know now has much more flow between the organizing ideas and between the grades, as we see here. There's things that are going in and out of each of the organizing ideas that are shared. Some remain within the organizing idea, but some things move around from one organizing the idea to the next. And if we could expand this graphic, we'd see that those same kind of things would connect to other grades as well. And so the question is, what goes into this new structure that allow that free flowing of and spiraling of ideas and information? And that's the use of concepts and organizing things around concepts in this new curriculum. This next series of slides is going to show you how that spiraling curriculum works and how the conceptual understanding that starts in kindergarten grows through the grades. So very quickly, I'm going to give you the K-6 picture in the organizing idea of energy, and we could probably work through each organizing idea with a similar kind of flow, creating some kind of a big picture. In kindergarten, we begin defining what movement is, and at the end of the day, energy is looked at through the lens of movement. What makes things move and how do they move is the whole study of energy for a large chunk of the elementary curriculum. The focus in kindergarten is that objects and animals move in certain ways, and by the time we get to grade 1, we take a look at the green items, and to the left, we see that there are influences that act on objects that move. And then we give a little bit more detail, more depth to the movement itself. And we look at that movement doesn't only happen in certain ways, but it also happens in certain directions, certain pathways, and at certain speeds. So we start analyzing object and their movement through a little bit more of a sophisticated lens than kindergarten. We put the pause on things a little bit and dive into the movement of two things, and that's of light and speed. We again talk about pathways and direction and so on with light and sound, not speed and sound. Light and sound are the two things that are looked at in the grade 2 curriculum. We look at how it behaves and what sources of light are through that lens of movement. Then we come back to the movement of objects again in grade 3, and the focus is on the contact forces. What are some contact forces that make objects move, and how does that work? Grade 4, that's the next slides. We add on to that understanding that not only are there contact forces, there are non-contact forces, and we investigate magnetism and energy. In grade 5 now, we look a little bit more at movement, and more specifically forces that allow objects to move in air and in fluids or water, and that's flight and fluency, and the forces we see of drag, lift, weight, and buoyancy. And then grade 6, again, takes a look at the whole movement thing again, and just clarifies a little bit that contact and non-contact forces are forces that act externally on an object, but there are some internal forces at work, such as I just have internal, but tension and torsion and so on like that. So those will be included in there. I'll fix up that slide so that when you get it, it'll have its actual words in there. So overall, when you stand back, you can see the big picture of energy and the ideas behind it and how they're related. And they do come back. Movement comes in, and we talk about movement through in and out things. Force is mentioned through a series of grades and so on. The more specific we get with the information, the more it stays within that grade. But you can see how fluid the ideas are when you take a look at the big picture of the K-6 organizing idea. The concepts aren't the only things that flow throughout. Oh, I'm jumping ahead of myself here. So when we take a look at grade 5, as Chris mentioned, there's 2 outcomes in grade 5. The first outcome focuses on energy, and it's related once again to movement and the behavior of objects and how forces act upon them. The key things are here of how objects and living things move through the air and the opposing forces, air and water, and how the opposing forces act upon them to make them either float or sink or fly or fall from the air. So generally, that was the way we're looking at things, and we look at a little bit at First Nations and traditional technologies and how understanding of those opposing forces has helped cultures to create technologies that assist them in their everyday life as well. And again, when we're looking at the behavior of things, we're really looking at altitude, speed, direction, and I forget the last one, height. That's okay. Vertical and horizontal movement. Another graphic that you have available to you, and the link is at the bottom of the next slide, is more of a linear oral one. You can see the words and the concepts written at the bottom. They're pulled out in the listed form there, and that can be useful if you're planning to see again what lies ahead into the next grade that you maybe should be focusing on, or looking backwards to the previous grades and saying what concept should my students, ideally once everyone has had a chance to teach the course over the last few years, what should my students be coming in with when they come into my grade? There's besides concepts, there are other things that flow in and out and around these silos, and those are the skills and procedures. You'll notice that I highlighted computer science and scientific methods, and that's because for the most part, those organizing ideas are laden with, of course, there's the knowledge associated in there, but there's lots of skills and procedures that can be used in each of the organizing ideas to help deepen the understanding of their knowledge and deepen their understanding of the understandings. So you can see computer science up at the top there by the tab is also included in there. So when we talk about scientific methods, for example, we know that there are a certain procedure to do with that. It's introduced in the organizing idea, but the intent is that investigative procedure and all the skills associated with investigation and looking at data and experimenting is used not only in the computer science organizing idea, but throughout the course itself. So the verbs themselves, you can see right off the bat that for this organizing idea, the verb investigate comes into play, that students investigate and compare how forces affect living things and objects in water and in air. And we know that the verbs that we see appearing in the learner outcome and the skills and procedure statement, those are the words that we get students to do those things, to demonstrate what they know, to demonstrate what they understand to us. So the more adept they are at those individual verbs, such as investigating and its sub-skills, the greater depth they'll have to their understanding, and the more they'll be able to demonstrate to us about what they know. We'll take a little closer look at investigating and investigations a bit later on. These are all the, it seems like a short organizing idea. Those are all the skills and procedure statements listed there. You can see we've got, conducting controlled experiments. That's an investigation, but using variables, which we can see when we're talking about flight. We can change certain variables, affect certain variables to see what happens if we change something and what the result has that on the whole. Again, practicing safe use of tools and things like that, because this is a great organizing idea for doing experiments and making trial runs and so on. Things like observation and explaining, they're really quite closely linked to the conducting an investigation. So when we practice the investigation, we're really going to be practicing all those things, because at the end of every investigation comes an explanation of conclusion and an explanation of the analysis and so on. And of course, the data we collect in that observations, it's often done through the observations themselves. So we can see very much a lot of skills and procedure statements in here connected directly to that idea of investigating. Because things are fluid and can move around, another way to talk about things spiraling in and out is that things transfer. So the skills and knowledge and understandings transfer from one organizing idea to the next. And just as a review of what we mean by that, we're thinking about the Hattie, Fisher, and Fry notion of surface, deep, and transfer, where students learn at a surface level or at a basic level what an individual skill or a concept is. So for example, the concept of predicting and the prediction. What is that? We can learn the definition at a surface level and make a few predictions. But as we deepen and have more experiences to making predictions, the better our student predictions will come, and likelihood the stronger they will get at explaining their reasons for making predictions, because as we know, predictions are based on our understanding and our current level of knowledge. So the more iterations we can get kids to do something like looking for predictions and making predictions, the deeper their understanding of that will be. And that's where we get to the deepen. Given many iterations, many practice to try the skills, to apply the concepts, to help them become more independent with their understanding. So we give them a brand new context and a transfer, which could be an assessment. They have a solid foundation of those individual concepts or skills to be successful on whatever assessment we give them. And same goes with the understandings. They begin at the deep level because we're already starting to connect concepts. We can't have an understanding without a full understanding of the individual concepts. So we're working at that level, and then giving students different contexts, case studies, videos, stories, experiences, to examine that, whatever it is they're looking at, through the lens of those understandings, and again, applying that in a transfer mode. So that's the way we are going to unpack the presentation for you today, is take a look at what do we need to know, and how do we prepare for an instructing a unit that includes these organizing ideas. So the way we're doing that is by backward design and beginning with the end in mind. We begin with the learner outcomes and the understandings. Those are really the end goals. Those are the big things we really need to focus on and develop, and have to give students many experiences working with those understandings, so that they can get deeper and deeper and more comfortable with them. So the way we do that then is to take a look at either the learner outcome or the understandings, and plan an assessment so that we know what that assessment is going to look like, and it'll help us determine what it is that we're going to need to focus on at the surface level and deep level, so that they can be successful when we give them the summative assessment. In this particular case, the summative assessment we have here is related directly to the learning outcome. You could click on it, Chris, and we could just take a quick look at it. You'll notice that the outcome is written in a certain ways. It says that is this the right one? Oh boy, I got the wrong link on there, I think, Chris. Sorry.
Oh, yeah, that's the flip of the other one.
Grade 5. Okay, if we get a chance to, when we talk about transfer, Chris, I'll include that one in there in a later slide. Yeah. So we'll just have to refresh it at some point. Sorry about that. And okay, there we go. I've got that right part there. I just didn't change this slide. Okay, we'll go on to the next slide. But at the end of the day, what it is an assessment where students, is a very familiar one that people would often do when it comes to something like flight, is to have students investigate different ways you can manipulate the forces by changing the shape and so on and the thrust of the jet, and see what effect it has on the flight of that paper jet. In this particular case, students then will need to know the steps of the investigation so they can work through that independently. And they will need to be aware of and have a good understanding of what things like force and opposing force means, what does thrust mean, drag, lift, and so on, because the assessment itself has them identify those things and work with those forces in there. So we know that at the surface level, we can do some pre-assessing to find out what they do know. And if they're lacking any of those things that we know they're going to need for the assessment, that's where we do some planning and instruction at the surface level, deepen it with more practice, and then we're in a position where we can give them that final assessment.
So just looking at some of the things that they might need to have in their back pockets that they would have had in a perfect world, had already gone through 5 years of the new curriculum, they would have a little bit more fluency in some of the terminology. But in this case, we might need to just go back and do a little bit of revisit. So again, if you're hearing things that, I'm talking about, and you're saying, I'm not too sure my students know that, then maybe we want to go back and just have a quick look and go through some things. But from kindergarten, even just going right to matter, what objects are, what properties are, that terminology. And that's where we unpack the whole notion of movement. So what is it? They define it. They go through different ways that we can demonstrate it, show it, identify it by the different types. So up, down, straight line, zigzag motions. So this is still all part of the experience that the students at kindergarten level are going through. In grade 1, we take that same information from kindergarten and expand on it and get quite detailed as far as what kinds of movement they could be. So they get very specific about how they would describe it from the perspective of direction, speed, as well as the pathway. So we unpack that pathway pretty well in kindergarten, but now we just build on it a little bit more, and we actually get them to do some slightly different activities that go along with that as well.
Jogs check.
And any one of the videos that are on any of the slides are actually enough, probably just as background knowledge or refreshers, if that's all we need, that you might need to with your students. Then we talk about sort of what are things that could influence whether or not I could move them. So the shape of the object, and purposely kind of grab this because I've got a flat surface, I've got a round surface. So flat surface might be able to slide depending on what I'm sliding it on and what it's made of. Versus a round, I could tip it on its side and I could roll it. So again, just what are the influences? Shape is one of them. The other one is what is the material that the object is made out of? And then the other one would be what is the texture of the object and how can that enhance or inhibit how I'm going to move that object. In grade 2, they really kind of took a little bit of a diversion there in light and sound. So I took the slides off of here, and I'm not sure that they're going to link to anything you're going to do here in grade 5. So we're going to jump straight to grade 3. And in grade 3, we really do get into that notion of forces. That was all the blue parts that we saw on the concept map. And we talk about what is a force and what kinds of forces are around us on a day-by-day basis, whether they're aware of them or not. We do talk about gravity in grade 3, but we don't unpack it in great detail. We're more talking about whether the force is a push or pull. We talk about whether it's a contact force, and in this case, you know, how does that get influenced? So the more force I have, if the object is lighter and has a surface in which I can actually move it, then I probably am going to be able to move that object, versus if it's a huge rock and I can push on it all I want, but it's not going to go anywhere. So this is a great little slide. If this is one where you need to do some review on, all of these are hyperlinked. So you could go in and just choose what you need to review with the student.
Hi.
Ask the students to describe from their perspective of what they've learned from forces, what's happening in each of the pictures, talking about the strength and the direction, and give us an explanation as to why that is. And then we also talk about simple machines. We talk about the inclined plane. We talk about fulcrum. So we ask them to unpack what they are, and maybe they already know what they are, but if not, we're going to teach them what each of those simple machines are, and how does that simple machine help us to move something and relieve the work and the effort. The line in the center is just something for them to reflect on. Look around your classroom, bedroom, home, find some examples of simple machines. Once I've learned at surface level information about what they are. We could then also give them some terminology that they've been learning now surrounding forces, and we could ask them to create a concept map with that. And as Ted pointed out yesterday, making sure, of course, that they know what a concept map is first, right? Don't just give the cards to them and assume that they know. There's some supports that are over on the left-hand side as well. But as they put these cards together, it isn't really necessarily how they put them down. It's the explanation they're going to give you that's going to tell us whether they really understood, right? So that's where we can find whether they have some gaps in their thinking or they really have some really good concrete understanding of what it is. So it's one way that it could be done. It's not to say it's the only way, but again, it's going to be the conversation that they're going to give us that's going to be more important. And then when we get into grade 4, we do talk about the non-contact forces. So these are the ones that we did yesterday. And we really are focused on 2 of the 3 that are shown here, and that is magnetic force and gravitational force. So we do unpack gravity. Again, not going into 9.8 We're not measuring anything in number wise, but we're talking really in terms of what is gravity, really unpacking what it is, how it comes to be, and how does it influence things that are on Earth or away from Earth or that are falling towards Earth and so on. We did talk a little bit about electrostatic force, just because it's a logical place for it. And, you know, you could do a real simple little rub the old balloon on your head kind of thing and what happens, just so that they get a sense of it, but you're not unpacking that as part of the curriculum in this grade. So we review quickly. If I took my backpack and came home and threw it on the table, that would be an applied force as the backpack is sitting directly in contact with the table. And what I don't see is gravity pulling down on my backpack and holding it in place there as well. So that's the piece that we want to start going now, and that's at non-contact. And so again, really, what is gravity? They might say the word gravity, but if they can't explain it yet, and they probably can't, they know it exists, but in scientific terms, what does it mean? We're going to give them the opportunity. And as I mentioned yesterday, the way the slides in grade 4 were set up were more of an investigation and inquiry, as opposed to here's the definition of gravity and now go find some information. I'm giving you the information and now I'm asking you to tell me what you learned from the information. In this case, it's a short video, just defines gravity. And do they even understand what the video showed them? There's lots of nice little models in there, but can they put that in their own words? And then if they can, then can we go find 2 examples that were different from the video that are being influenced by gravity? So just to make sure that they're starting to get the idea of that surface level information. I could go a little bit deeper. I could ask them, once I understand a little bit more about gravity, and I know that it's coming from the center of the Earth, that the Earth itself is a magnet, how is it that I would weigh something different on Earth than I would if I was on the moon? What's the difference between them? So again, if I'm understanding the concept of gravity, I'll be able to understand and answer that question for you. So we're really listening for gaps. They might have it right, what they've said, but it's not complete. That's what we're looking for. So conduct an investigation to demonstrate magnetic forces. Before we even ask them to do something like that, we need to make sure that they know what an investigation is. Did you want to go through that now, Ted, or not?
No, we don't. Let's maybe wait till we do that. I have that summative assessment on the later slide. So I'll just talk about it then at that point, Chris.
Sure. Absolutely. So then when they go through an investigation, they need to know what the steps are of the investigation, and we'll unpack that as Ted said. But now we're also going to talk about, I want them to build something that can move without being touched, without having a motor in it. So in this case, our challenge was, can you build a device, a vehicle? And can you make that vehicle move without actually touching it? No contact forces. So in this case, we're likely moving them towards magnets. And we're asking them, how would they learn from what does a magnet do? How does a magnet work? So they learn all about magnets first. And then I can come back to my overarching question of, what does a vehicle that is powered with non-contact forces look like? What could it look like? So again, these 2 tell them basically what it is. And this one will show them some of the samples of electromagnetism in there as well. So again, they were set up in such a way that we're going to grab from them what they have learned from the video. If we need to fill in things at the end, we can do that. But we just want to see if they're catching on to the demonstrations that are being shown to them. We can then go further. We talk further about how the Earth is a magnet, how it works. We've understood magnets of having north and south poles. We can talk about the Earth having north and south poles, and how do those work? And what do these lines reflect, these magnetic fields? What are they? What's so important about those? So then how can I make a model car that moves only with magnets? So design a model. Would your vehicle be able to go up a slight incline? Since we did simple machines or inclines as well, we talked about that in grade 3. Would they be able to do that? And is there anything that they would have to change in the design of their model? Okay, we don't want to get deep into design here. That's not the whole idea behind it, but it's something that's a great challenge for students. And is your vehicle able to go forwards and backwards? Could I change its direction, or is it only going to go in one direction? And if they could record the event, use their phone, use an iPad or whatever, where they can watch their vehicle, and then we can look at it as a class and analyze it and say, you know, what did we see about so-and-so's? Ted's went that far. Like, it was amazing how fast it went, and he was able to make it go faster and slower. And how did he do that? And mine didn't. Mine just kind of chugged along a little bit as it went, and then it kind of died as soon as it hit the inclined plane. So again, we can use those videos as teaching tools at the same time. So let's have a look at grade 5. We are, again, going to talk about design. So this is very much the summative as well. So design something that can fly. Now, it doesn't have to be a paper airplane, but again, that's probably a likely one that students are going to choose. So can they find something that's going to fly that they can make? And they might look up different designs. There's lots of them on the internet that they could choose. Some of them definitely going to be better than others, but we're not going to tell them which ones those would be. So what materials will they need? So basically, they're setting up their own investigation. They're going to design their device, and they want to see if they can design it so that it flies the longest, the furthest distance to start with. And then we want to measure how far did it go, right? So again, we could record that, and then we can keep our data as we go along. We can compare different groups or different individuals who have their flights. And then what adjustments would you make for it to go further? Did they understand anything about when we talk about that? Now, remember, this is up front. We're saying to you, here's what we want you to do. This is your big project. You're going to be building it as you go along. So if I want it to go further, what do I need to know about flight? What is it I need to know that makes things go further? So that's the piece that I'm going to have to worry about as I'm learning and I'm doing the teaching, is have I addressed some of those forces, and how do planes go and how do planes lift and those types of things, which is what we're going to talk about. What would happen if we wanted to add a weight to my plane? Do I have to make any adjustments for it to still fly the same distance that it did before? Or was that just not going to happen, right? And that's very possible. Maybe I made my paper plane in such a way that if I add anything to it, nothing's going to work. So what adjustments might I have to make? So to make all of those happen, I need that sort of surface level information first. So one of the things that, and indulge me here, this is my little, got to take my side trip here, but I really kind of want to. When lift plus thrust equals load plus drag, anything can fly, which was a sentence that came out of someone's mouth in a show that used to be on in the 1960s. And I know I'm dating myself, but I'll just play a little bit of it. So they had these pretty interesting habits that they were wearing. And the whole premise behind the show was, for some reason, Sally Field, who played one of the nuns, whenever the wind would blow in the right direction, she would just take off and start flying. And so she would have to explain to people, how is it that she could fly? And it was based on her weight or height and the height of their habit that they were wearing. She would always say, when lift plus thrust equals load plus drag, you can fly. And really, that is exactly sort of the whole description that we have when we're talking about flight. So when we talk about how do you really make things fly, what do those terms lift, thrust, load, drag, what does that really mean? And that's what students need to know. And so one of the questions that students will have to unpack is, you know, we see planes that take off from airports. They might have been on a plane already themselves. Why can't that plane just keep going? Like, why doesn't it just go up to the moon? And that's an important question to ask them. And they may never have thought of that. I know actually I didn't when I was starting to read through some of the materials, but I hadn't thought of it in that light before. But it really does help to explain how something flies. And it also explains why a normal 747 could not go to the moon, what the purpose and the reason is. So again, why can't airplanes go to space? We'll give the students an introduction to flight. What is it that lifts this big monstrous plane off the ground? And what is it needs to stay in the air and not just keep falling straight down onto the ground? What is it that keeps it up there? And what is it that space doesn't have that would definitely not allow the plane to go there. So it's one of those inquiry. I'm going to show it to you first and see what you've learned when you come out of it, as opposed to me sort of stand up and deliver and providing the information to you. This graphic comes from one of the resources from Newfoundland. Actually, we've asked them to send us their science books just to see what their books look like in comparison to what we're teaching. And this is one of the ones. They have one of their books in grade 6 is a beautiful match to our flight. But here it just really unpacks, again, not in detail, but I could use it as a graphic and see what they learned from the video about what is gravity and what does the force of gravity really mean, that it's always pulling the center of my object down. What do I talk about lift? What does that mean? And why is it that this is lift? Like, why does the air lift up this plane? The plane's so heavy, it just doesn't make sense for it to be lifting up. Thrust is that force that's moving it forward. So obviously powerful engines are definitely part of that. And that would be a conversation that most students would come up with a spaceship as well, right? They'll say, well, they've got these big rockets on the bottom that are lifting it up. And that's exactly true. And then drag, we're talking about, what does that mean? What is drag? We hear it, but what is it? How does it affect what happens in here? So these are, again, just a graphic that you might wish to use. This one also just shows the same words that I just talked about, but shows them as opposing. So the opposite of pulling down gravitationally would be to lift up. So these are opposing forces, and thrusting forward would be the opposite of what's dragging me down, holding me back, right? So these are what we call the opposing forces. And we would expect students to be able to at some point tell us why they're opposing. Why do they call them the opposing forces? So why are they the opposites of each other? So this down here is just a bit of a simulator. It's not a video. It just shows students how air moves in order to lift something up, and how they might go about testing some things. Okay, I'm just going to mention one more thing on this one here, on the one that's at the back. I'm just going to go back one more. The video that's included in this one here actually asks students to, when they're traveling on the highway with their parents in a vehicle, to put their hand out the window. And that's a perfect example for them to learn what it means to have the air current against their hand. So when their hand is flat, it's fairly easy. Doesn't matter how fast dad or mom is driving, because the air is just going to go right over my hand. But if I just tilt my hand up a little bit, then I can really feel that force of air. And that's really the plane. That's really what the descriptor of a plane is going to be, to get that plane off the ground. And so it's an important little video that really helps them to understand some of the pieces that they would sort of unpack as they go through. And then we move to buoyancy, so which is another way of sort of lifting something up, only it's not in air, it's lifting it up in the water. And so is gravity the same in water as it would be in the air? And yes, there are gravitational forces in water. It's called buoyancy. So the force of gravity, or the force, buoyant gravity or buoyant force, there's what I was looking for, is described here and shows them, and just simple little examples of things of just putting them into a dish of water. Again, I could just come up and say as a teacher, this is what buoyancy means. This is what it does if it's going to be really heavy and it has this and it's going to drop. Or I can let them watch the video and see how are they unpacking the truth about what would float and what wouldn't float. And how will they make the decision when we give them 10 new objects? Will they have understood enough for them to make predictions about what would or would not float, right? So that's that moving forward.
In this experiment, we will learn.
So again, there are some buoyancies, some definitions. If they haven't got it, this is right out of your curriculum. This is not something that's coming from a different resource. A lot of the knowledge section in this particular organizing idea has a lot of definitions in it. That's really what it is. So here you see what it is. And now you've got some additional videos that you could show them. Sort of my comment in the past has been, I wouldn't show them all the videos on one day. I would use one every day, good review. Also, every video always brings just one little extra piece into it. So just expands my thinking or gives me a different perspective.
I should add that these videos, Chris, they go a little bit deeper into buoyancy than what what the curriculum does. It does mention things like density and so on. But there are some good examples of their buoyancy at work as well. So if your kids are ready for them, maybe they can handle the idea of density. So.
And they have seen the word before, they just haven't really unpacked it in a big way. So here we have, in terms of force and liftoff, so we're definitely getting into deeper thinking now. I've understand sort of that surface level terminology. We've gone some pretty simple examples already, and we've given some opportunities to explain. And now in terms of force and liftoff, explain why a large plane needs larger wings than a small plane does. So do they understand enough about what they have learned to lift something up to fly? Why do I need to have bigger? Why can't I just have these little wings on this plane, right? So some of the things are going to be obvious, but are they using the right language? Are they giving you the explanation using the terminology that we've been teaching them? Okay, and then we might want to even step that one step further. How is that compared to an eagle versus a sparrow? They're both birds, they both fly. Why might an eagle have bigger wings than a sparrow? Or whatever, pick whatever. Budgie bird if they have a budgie bird at home or something, whatever what makes sense to them. Relate my understanding of forces and flight to one of the following man-made tools. So one of your outcomes is also to expand how, let's say, natural, in the natural world, how were things used? So if we talk about not necessarily just indigenous culture, but indigenous culture using bow and arrows, there are people that still hunt with bow and arrows, right? So what do I need to know about the flight path of an arrow or the construction of an arrow that's going to make sure it goes where I want it to go? Or a slingshot, or a fishing spear, or a javelin, or whatever would fit in this category that they would find of interest or let them pick. And then include a label diagram in their explanation. So don't just show me don't just tell me what it does, show me what it does, and label the steps along the way. Relate your understanding of forces of an object in flight on how an eagle in this video, so I'd like them to watch the video, it's only a minute long, but it picks up a salmon that's half its size. How does it do that and still take off from the water and move forward? So what adjustment might it have to make in its wings to do that? I was saying to Ted earlier that I got a little carried away with some of the videos last night watching them.
That they can
Where they were carrying away deer or they were carrying away an entire wolf. And I thought, wow, you know, the balance that bird must have to do in order to carry that weight is amazing. So the other experiment and investigation that we might do with the student is, are all liquids going to give me the same result for buoyancy? So if I were to try water, I've kind of seen an example of water now, and I might give them 10 or 8 new things that we've never seen go in the water. But what if we changed out the water to be also including maybe olive oil or deep frying oil or something, and maybe pancake syrup or corn syrup, just getting different kinds of liquids that they can see what happens. When I drop those same items into that, what would my prediction be? What would, and then test it out and see how accurate I was. So again, just coming together and seeing if air is a liquid, and I think a lot of students forget that air is also considered a liquid. How does that work? When we talk about balloons that are just blown up by us for a party on our own, we just blow it up, tie it off, versus balloons that we fill with helium. Do they both float the same way in the liquid of air? And the answer is no, but why not? Okay, and we don't have to get into great chemistry here, but again, they should be able to see that things are a little bit different, right? Why is it being treated differently? So possible, you know, some of the ones that we've shown you already could be transfer questions for you, depending on what you've done with the students, and other ones, these could just be other deep questions. It just depends on where your unit has been structured and where you want to go with them. So explain how birds and kites fly using your knowledge of forces in flight. So pick a kite design that they want, pick a bird that we haven't talked about, and how are those two the same and how are they different? Great Venn diagram question too, right? We could put that on the floor, just take 2 hula hoops. Describe the reasons and forces that act on a supertanker. So if a little boat, a rowboat, can float, how is it that a supertanker that might be like a kilometer long and full of oil and whatever else, why does that thing not sink if it's made of metal? So again, did they understand the terms of buoyancy? Did they understand how something is floating in order to explain that question? Use your knowledge of buoyancy, compare the speedboat and a watercrawler. So a speedboat has power is skipping along top of the water versus the little bug that walks right on top of the water. How's that working? So again, we talk about those different pieces of possibilities that they could go to.
Chris, if you could just go back to that other slide and just, I'm sorry, refresh. I do have that assessment piece there that maybe
In
we could
this one?
go back. Just know the slide that you were just on with the assessment or transfer pieces. It doesn't show up at the bottom because you'll have to refresh your deck.
Okay.
I'll cut this out of the video.
No worries, all good.
Thanks for your patience, Rhonda. There we go. So the assessment piece that you see there was one that I was going to have at the front end. And I wanted to highlight this one because it does point out a couple things that maybe you should be aware of at the grade 5 level. If you haven't done investigations with your students before, you want to practice it. And Chris, we're going to scroll up and down through this a couple times. And we're going to go past this first part because it's really talking about the assessment piece. I just want to maybe mention a little bit about the investigations at the grade 5 level. The investigation always begins with a question. Students can generate them or not generate them. And maybe I'll back up even a little bit. These steps in the investigation are lined out or outlined in the grade 2 organizing idea in scientific methods. You won't find these steps anywhere else that you're going to use in grade 6, but you have to go back to grade 2. So these are the ones that the steps that we're following. There are some additional things that we add on to those steps in terms of going in greater depth at grades 4, 5, and 6. And I'll mention a couple of those things that we go deeper with in grade 5 after I just quickly review those steps in an investigation. So it's asking that question. If you scroll down a little bit more, just really quickly, we'll talk about then predictions. We have the question, we make a prediction of what might happen, and we hopefully have a reason for those predictions. Then we do our experiment, and you can see then there's room for observation after you do your experiment or your work with something. After you make your observations, then you analyze, you look at the data. Well, what does that data tell you? What do you notice about what's happening when you compare the data with one another? And that's where the analysis comes in, is looking for those trends, looking for those pieces. And that's going to help you with your conclusion at the end. And the conclusion at the end is going to answer the question that was given, and students go into a little bit more explanation. So those are the steps, really. Ask the question, make a prediction, collect and record the data, do your analysis and make the conclusion, and then explain it at some point later on. But I want to point out at the grade 5 level, there's a couple other things added on to it. One is the whole notion of a controlled variable and non-controlled variable. With this assessment, it's not in here, but you can see how I could put it in. Because in this assessment, now we're going to go scroll back up to the top, Chris. Students are going to do something similar to what Chris talked about earlier, and that they're going to have a paper jet, and they're going to test it and test its flight on behavior. So you could see the outcome that I'm looking at there at the top. And you'll see I have some words crossed out, and that's purposeful. If you could just scroll up just a little bit higher, Chris. There it is. So the entire outcome is students investigate and compare how forces affect living things and objects in water and air. And I'm limiting this, I'm just sort of saying I do only a partial part of the learning outcome assessment because there's various pieces to that when you look at it closely. But students investigate how forces affect objects in air. How do forces affect objects in air? So to do this, they're going to be doing a paper jet, and I have a little bit of a preparation instruction. There's a little video that tells you how you can make a paper, not necessarily make a paper jet. You'll want the students to make a good solid paper jet, but one they could add a little paper clip to the front that they can use as a hook. It's going to require some taping and some stapling. And that little video, that link is there, you'll see. As well, if we're going to be talking about grade 5 and talking about control variables and so on, when we launch our jets, we want to make sure we can control the thrust. And so students can make, or you can make ahead of time, this little launcher. It's the top view of the launcher. So if you can imagine a piece of wood with 2 nails at the end, and then the elastic stretched like that, with some marks in there. While when you hook the elastic that's at the end of the plane and you pull it, you can always keep a consistent thrust. So that's sort of the ways we could talk about controlling variables with this. So students are going to make a plane, they're going to be thrusting it, and then they're going to get their baseline. So that's the next series, the next page looks like really quickly, is that students are going to launch their plane and get some preliminary data. So if we can scroll down to the next page, Chris, a little bit more, there we go. So you make their observations, right? What would you consider the speed? Is it fast, slow? Measure the distance, determine how straight the flight was. Did it go to one way? How level was it? Did it go up right away? Did it go down right away? Or did it fly straight and level across? So students make their observations. And then we go to the next slide. That's their preliminary data that they're working with. Now that's kind of their control part. And now we fix things one at a time. So the flight characteristics, in other words, in the learning outcome, it says, how does force affect the flight? Well, one of the things that flight can be affected is speed and distance. So we have a baseline for speed. So now we ask the question, what forces can you adjust to increase the speed and distance of your jet? So we could do a couple things. We can maybe increase the, we could decrease drag by maybe putting something a little less, a little smoother than paper, for example, or we can increase the thrust. But those are the things that students are going to determine, and they would have to say, well, I think if I increase the thrust, for example, I think the speed and the distance will go greater, and so on. And then they make their adjustment and they carry it out and do the observation. And then they take their paper jet again, and we do the next thing for launch 3. What are 2 forces you can adjust to decrease the speed and the distance this time? And again, we're talking about forces. So they're going to say, well, I could decrease the thrust. And that's why we use that little thing that can measure how much thrust is being used. And what else can be done to decrease distance? Maybe the other force at play might be weight or load, right? And so that's what students do through this experiment. And then they make their observations and explanations and conclusions at the end to bring it all together, how forces affect flight. So this is the one I was going to show you at the start, but you could see how, yeah, that surface level students are going to need to know a lot of things. They're going to need to know all the things about forces and flight and so on that Chris talked about leading up to this slide deck. So this is an assessment. This is not an assessment you have to use, but we just want to use it as an example. If we know what we're going to assess before we start our instruction, we know what we got to help focus on for kids to do. They're going to have to know how to do an investigation, analysis, prediction, so on before they do this. So there's some front end teaching that would have to be done before you do an assessment such as this.
Okay. Do you want to keep going?
Sure, I'll keep going. As Chris mentioned, there are 2 learning outcomes in this organizing idea. The first one was related to energy in terms of forces and what causes movement. This second outcome refers mainly to energy as a resource, and that energy of things that makes things move or allows movement to happen, and that's energy. And the real focus is on energy as renewable, non-renewable resources, that we have energy resources that meet our needs. And there are examples of an exploration of some of the renewable and non-renewable energies. And that's just the one cusp actually for this outcome as well. So if we were to, I'd just go to the next slide, Chris. Right, once again, you can see with this learning outcome, investigate and analyze are there again. And investigate are those steps that I had in that sample assessment. And we know analyzing is one of those steps in an investigation. So if we can create an investigation where students explore resources that they should be able to do, hopefully use their investigative tools to gain the understandings. We're talking about some of the skills and procedures that are looked at in here. We're looking at comparing renewable, non-renewable energies, discussing advantages, disadvantages, and examining how the different parts and regions of Canada fulfill their energy need. The sample assessment I have in this one, if you can go to the next page, Chris, is again focusing on the learner outcome, which reads students investigate and analyze various energy resources. I'm doing something similar to what the comparison skills and procedures was, but the investigation question might be, what are the similarities and differences between renewable and non-renewable resources? And if you've done a lot of upfront work with students at the surface level about comparing and contrasting, you would know that when you compare and contrast, one of the things you're going to have to generate first are those criteria. On what basis are we going to determine similarities and differences? And there's some possible criteria that you may want to have students look at, such as its sustainability, its impact in terms of environment on the air and water, whether it can create energy dependence or independence. In other words, do we have to depend on someone to give us that energy, or can we produce that energy right here? Its availability, its effect on land use, its reliability, and the cost of production should be a different one. So they should be separated out. And is there the available technology? How much available technology is there? And so with that, then students collect their data. Now, in this type of investigation, you'll notice that it's not doing an experiment. You're doing basically research. And so that's where this is probably, I think, a repeat of that other page, Chris. I think I'll just have to fix that up. Scroll down to the bottom there. And then after you have that, students have their data, then they look at that data and say, what do you notice when you're looking at this? What are the trends do they see? What can they come up with when they look at their data? And then what kind of conclusion do they make at the end, which is the next piece. So it's the similar steps as an experiment, but except we're not experimenting to get the data, we're doing research to get the data. So what does this data tell you about the similarities and differences between renewable and non-renewable resources? And again, because the investigation has kids, one of the key things is asking questions, and the investigation question is given. After their investigation to gather the data, we want to give kids an opportunity to show that they can ask questions. I've learned this, I found this out through my research, but here's 3 questions that come out of the research that they've done. And again, that's something that kids need practice with. It's not an easy thing to do, to come up with a question after you've learned something. So that's an example. If that may be my summative again, you can understand and see how at the surface level, before I get into that, I want to make sure they know something about research, how to document research, and so on. Because there is a single point rubric for a research assessment. If that's what you want to do as part of one of your research, one of your assessments in terms of gathering data. This is built largely from the grades 4 to 6 competencies that we can find from Learn Alberta. We pulled a few different things from the different competencies to create this for the research. And it would be something, again, you'll want to have kids practice doing with small little research projects to know what it means to verify the accuracy, and how do you reflect on the information that you've gathered, and so on. So again, that can be tinkered with and tailored to suit your class's needs, but that would be something, again, to work at the surface level. You don't just we're not just going to give them that research assignment at the end and say, I'm going to mark you on your research. Definitely want lots of practice at the surface. And when they deepen that through little mini research practice, we can apply that in a larger summative assessment afterwards. And so once again, another graphic, say if we're going to use that assessment, so at the surface level, students again need to know the steps in investigation. What are some of those research skills? And some key concepts will have to be developed before they are given that final assessment. If you want, there is a concept attainment there that clicks on what are resources, and it goes from resources to renewable, non-renewable resources to energy resources. If kids aren't familiar with the concept of resources itself and what energy is all about, what energy really means. So you can try to use that if you have give it a shot.
So again, just going back to, if you're going to think about that summative that Ted just went through, we're going to need the basic foundational information first. So they need to know, first of all, what resources are, if they don't already. And it would be interesting just to ask the question, what are resources? What can you name? What are they familiar with? What have they heard? I mean, we live in Alberta, so oil is always one that comes to mind, but what else do they know is available? And just making a list on the board and having a bit of a conversation with them about what they know about them and where they are going to go with those. So a couple of little books that I have found that are good. One is called Energy, and this would be a great one to have in the classroom for this unit. It fits very, very well into the kinds of things we have to talk about in grade 5. It's one of those few books I found that kind of really nails one complete outcome in a grade. In this case, it's year 5.2. And it's not extensive in its descriptions, but it has more than enough information for them to get started. So if I was having them break out into groups and I wanted them to pick, they could easily look at the information that's in this book and get enough feedback or enough information to say, hey, this one really interests me. I want to go and find out more information. So it would give them enough of the groundwork and sort of the very surface level information that they need just to get started. So this is your cover. If you have sales in the school already, this is not new. These have been around for quite a while. So if you have the sales series in your school, then you have this book already. So you might want to just go find that one. Again, I might be more inclined to use a case study approach where not necessarily everybody's going to do every resource right off the bat. So I might have them select, or I might have them draw, a card out of a bag and say, here's the one you're going to do. Or again, they can just choose as long as everybody's got something covered. So it could be a case study where I give you two and we compare them, or it could be one in which you're just going to do some research and now you're going to come back and do a bit of a presentation from that research about what you found, what was the information, all the different components that I was looking for. So again, it has to fit into the design of what your unit looks like. If that fits, great. If they're going to do a little bit of research on their own, you could even steer them towards, let's say, this slide. There's lots of information on the resources. I will say, though, that lots of them get very technical and very deep into the scientific products that are manning it. In other words, the machines that are running it. So we do have to be a little bit careful on some of the terminology that's there, but these are grade 5 students and they're pretty versatile and they're pretty able to handle some things. So if they do come up with a few things that are a little bit beyond, the ones that are in here, there's very little that goes beyond what they need to know, but definitely enough for them to be able to explain, let's say, what's hydroelectric power? How does it work? Why do we even use it? At some point, we're going to want them to say, especially in the grade 6, we want them to say, what is good use of energy? What is the best use of energy, and what's sustainable? So we want them to start thinking in those terms too, when you're not just finding out what it is, how does it work, but maybe prompting them to think. They don't have to necessarily be assessed on that, but thinking about, is this a good, healthy part of our environment that we should be considering? Or is this maybe one that we should start thinking about what else could we use in place of it? The one that's at the bottom is called solar energy, but it actually, I put a little note on the side, it really unpacks every non-renewable resource as well. So this is a short but very powerful little video, covers a lot of ground and would be great to even show to the class as a whole before you break them out into small groups, if that's the way you want to go.
Hydropower. Hydropower, or
Come on, there we go. And as I had mentioned with the grade 4s, there is a resource that we have found. They are free textbook resources that we have access to. You don't have to use the whole thing, but where I can find a match to what we are teaching, I am highlighting them in our resources as a possible piece. I'm not suggesting that you have to use this, but there is a student resource that goes with this and a teacher resource. The teacher resource has about 200 pages in it, so it covers both explanation as well as investigations that you might want to embed within some of them, or some open-ended questions that you might want to use. It talks about the renewable energy sources of wind, hydroelectric, solar, geothermal, and tidal. And it talks about the non-renewable, fossil fuels and nuclear, so which is really the two that we want to talk about in our curriculum. So it's a nice match. It's a really nice match. These are hyperlinked right now as PDF documents, so you're welcome to download them and use them. This is what the cover looks like. And in the student resource, it really is a bit of a book, and it just unpacks for them each of the individual resources, what it looks like, what does it mean, gives them some terminology. In some cases, goes a little bit further in the operations of the machinery that actually functions to make that renewable or that resource usable to us. But that's okay. That's all right for them to learn a little bit beyond that as well. So there's a piece there that you might want to consider using if that's something that you need more of. Another possible assessment question that you might want to consider, the wind turbines, once they've talked about wind energy, wind turbines use blades to collect the wind's energy. Explain how wind flowing over the blades, creating a lift similar to that used in planes. So can they make that analogy? Now that I know how a plane lifts up, how is it that a wind turns these huge arms that are made of metal? What is it that's functioning almost like a plane to get those to turn? So it's the same kind of a principle. Another one is I traveled in Greece quite a bit. And one of the things that I noticed when I was there is that they all have these cylinders that sit on top of their homes. Now, it's been a while since I've been back there. But I did ask, I said, what are those cans on top of everybody's house? And that's their hot water tanks. They use the sun to heat their hot water. And so there's a limited amount that you can use at any one time, obviously, because it has to refill and regenerate to get heat. And now I see that they made it in the things that I was reading when I went to find a picture of it. They were saying that in 2016, there was a huge push to include solar panels into the heating of those cans or tins, cylinders. And so this is a great place for kids to tie solar energy into how this functions on a day-by-day basis and what value it is. It's a cost thing as well. I mean, they didn't have solar panels then, and it was they said we can't afford the electricity to heat a hot water tank. We won't have the space in our homes, which they didn't, for a hot water tank. So it was really a structure of economy and affordability that makes this a very functional piece. But they also live in a really hot area, so why not use the sun to do that? So again, just some possibilities. This is not unique to Greece. Most European countries have some form of that. So if children have traveled at all, they probably have seen that in other locations as well. Some other books, both of these are from Scholastic, and these are excellent books that would fit very well with grades 5 and 6 in energy. Solar power and water power. There's a series of 4 of them. So they're wonderful little books, and they really unpack things in a wonderful way for the students to understand. We have another Max Axiom book, which goes through renewable energies, and again, written sort of in that cartoon graphic form, which the students like, but very technical as far as science is concerned. And then there's 2 others, Powered by the Sun, which ties well into solar energy, and then fossil fuels. How do we get fossil fuels? Where do they come from? How does that develop over time? Why are they in the soil, etc.? So there's quite a few books that fit well with the energy unit in comparison to some of the other organizing ideas that we've unpacked. When we talk about, again, taking computing science and connecting that to our organizing idea of energy, Engineering does a great job of providing you with a slide deck and a video that really ties in the organizing idea of computing science into what it is that you're doing. So remember, we don't want that as a standalone. We want those to be done embedded in the other organizing ideas. So again, you're welcome to use her slide deck or the ideas that are in there, or just as is. And the video on how to unpack those is right above. And that is the end of what we have available to us for our grade 5 energy, of which quite a bit, I will say, is going to start to kick off a little bit of grade 6 as well. So there'll be things that will overlap there for sure. I'll just stop our recording and let you know if there's any questions then. Let me just see if I can get it to kind of go.